Okay, let's talk a little bit about what predictive modeling is doing intuitively. So I want to represent an example here, right? So I've got this thing, and this circle represents an uncertainty, right? It's something that I don't know, and it's a value that if I did know, it would provide me some benefit. So let's say this is like the price of a home. Let's see if I'm any good at drawing a house here. All right. So let's say this is the price of a home, and I want to know what the price of my home is. And if I had no other information, I would have to just take a random uniform guess of all possible prices in the known universe as to what the price of my home is. But as you might guess, in fact, what I have are pieces of information about my home that can give me some knowledge about what this uncertainty is, right? Like how much could I sell my home for? So maybe I know what like the size is. And maybe I also know my neighbor's home price. And maybe I also know my address or my city. Right? And so you can see that these other pieces of information allow me to know something about this uncertain value. So these other pieces of information in the machine learning context are all referred to as features. Right? So these are features. And features are observable quantities that give me some amount of information about the thing that I don't know. Now, what ends up happening in the real world is that it's not just this simple. You don't just have a set of features. The features themselves could also be influenced by other components, which themselves could be influenced by other components, which themselves could be influenced by other components. And so this gets to be complicated really, really quickly, right? So maybe now I have all of these uncertainties, some things that I can see, some things that I can't, and the system and the world itself is extremely complicated, right? And this extreme complication makes predicting this value here very difficult to do. And so what's happened is that there are two methods that you can use to best predict this value. And so practically speaking, I want to introduce two concepts, right? So practically speaking, the way that most uncertainty is fixed right now is through an expert. You have an expert come in, and this person has a lot of experience, right? And they can come in and they can tell you, I think I know, based on my experience, what the price of your house will be. You know, maybe this is a realtor, and a realtor's seen a whole bunch of other homes for sale. They know small nuances. The expert would know that, like, okay, it doesn't matter what your neighbor's house is worth. It does matter the size. It doesn't matter your city. But maybe it also matters what this is and this is, things that maybe you didn't know. So the expert would come in, and then through their knowledge, they would say, no, these are the things that you want to pay attention to, and that will be the best thing that helps you predict what the value of your home is going to be. Now, in data science, obviously, we're going to be quantitatively driven. And so in data science, we are going to ask this question, can we improve on what an expert could do in this situation? So the other method for figuring out what the value of your house would be are these quantitative models, right? And the quant models are going to incorporate as much information as they can, right? And as much information, let's say the quant model's in orange here. So the quant models are going to incorporate as much information. Maybe the city doesn't matter, but maybe it matters a little. And maybe your neighbor's house does matter a little. And yes, size matters a lot. But then the quantitative model doesn't have the same restrictions as an expert in that it can incorporate a lot more information, and a lot more information from a lot of different places. Now I should pause here for a moment to mention, beating an expert prediction is actually very difficult to do for quantitative modeling. So I don't want you to look at this and say, oh yeah, all quantitative models are going to be better than experts. It's actually a very challenging thing to do to improve on expert prediction. Like, so for example, say this wasn't a home price, say this was whether or not you had cancer based on a given x-ray. It's actually extremely difficult to build a predictive model that can outperform the best radiologists that have to perform this task. But you can see that we do have this dichotomy. We have this dichotomy between an expert and a quantitative model. And in data science, what we want to do is we want to start leaning into building quantitative models. We'll get to specific quantitative models in the next chapter, but for now I want to focus a little bit on how an expert works. And in the next section, I'm going to ask you to build expert type models on an example data set. An expert, this expert information here is called a heuristic. A heuristic is a rule of thumb. Right? So they're going to have these complicated sets of rules that then produce a prediction, and it's usually based on some type of pattern recognition. And so we're going to develop our own rules of thumb, and then later we're going to compare those rules of thumb to other types of quantitative models once we're ready to build them. Okay.